Okay, so welcome back. This is part 4 in our series where we're helping you to understand a very important concept in engineering and software development, and that is the concept of state machines. And it is a concept that helps you in the real world to control real world equipment, and it's used in many places. And what we're doing in this series, I encourage you to look at the previous videos in the series to explain what's going on and how we started to learn about this. And what we're doing is we are simulating a state machine that's used in the real world, and that is a controller to control traffic lights at an intersection. And there are many other places we can use state machines. However, we're going to use this very simple concept that you're probably familiar with to show you how to design and implement the software and even the hardware that goes with something like a traffic light controller state machine. And what we're going to do in this video is we're going to modify what we've had so far for a very simple application to simulate a state machine. And what we're going to do is we're going to add some inputs, some user inputs, and to make this able to act like a real-world controller that a technician or operator can modify. And also we're going to see how we can implement things such as occupancy detection sensors to sense traffic and to change the response of this state machine and the traffic light controller. So now let's take a closer look at the occupation detection sensors and what they do and how they might help us to understand state machines and how we might implement them. Now, of course, not every intersection is going to have these occupation detection sensors, but they do provide an opportunity to understand how you can have external inputs into your state machine that might be modifying the different states that your system is going to go through. So what are the occupation detection sensors and how might we implement them? Well, first of all, if you've ever driven before and you've come up to an intersection where they have occupation detection sensors, you might have noticed that the pavement is cut into a rectangle. And these sensors detect, for example, if a car is coming into this red light at this intersection, the occupation detection sensor will send a signal to the controller, the state machine controller, that says, hey, I know there's traffic running on this horizontal road going left to right and right to left, but somebody just showed up this vertical road at the stoplight. We need to suddenly change state to allow this car or any other cars that are on that vertical road to travel on that road, so that the horizontal lanes get a yellow light and then a red light, and then this vertical lanes get a green light so they can proceed. Now, you can also imagine that not only can they be used to detect the presence of a vehicle at a stoplight, they can also be used to detect and measure how many vehicles are passing that detection sensor every minute so that you can determine what is the rate of flow. So for example, if on these horizontal lanes, we detect there are many cars passing the detection sensor every minute, but on the vertical road, there's only one every 10 minutes, then we can add that to the logic and say, well, I don't really need to change the lights. I can leave the horizontal lanes with a green light. There's not a lot of traffic in those vertical lanes, so we can just change it only when we absolutely need to. So there's a couple reasons you might want to use that in your logic. And what are they going to ultimately do? Well, what they'll do is they will ultimately change the state, or they will initialize a state change. So it's ultimately might be affecting the timers that are being used for each of the states. You can say if normally, there's a 60-second green light in these horizontal lanes, if a car pulls up, it may change it immediately to a 5-second remaining timer, and then it will change the state. So ultimately, it's going to probably affect the timers, but let's go through and see if we can figure out a conceptual idea of how we can implement these occupation detection sensors and any other external inputs. So here is our application we developed in the last 3 videos. I encourage you to take a look if you want to see how we got here. But basically, when we run the simulation, we're doing it asynchronously. We set the state to state 1, then we set it to state 2, 3, and 4, and then we loop continuously to set those states. And in that set state method, previously what we did is we set the light colors and then we waited a fixed delay. We had a number in here for the, in this case, the horizontal lanes to have a green light. The first thing we're going to want to do is we are going to, instead of hard code that, we want to have a variable for each of these delays. So for example, where we've got the horizontal lanes with a green light, we want to have a horizontal delay in milliseconds. And then the next state is where those green lights get a yellow light, a caution light, and we're going to have a yellow delay in milliseconds. And then when the vertical lanes get a green light, we're going to have a vertical delay in milliseconds, and then back to the yellow delay in milliseconds. So the number one thing is we're going to want to define 3 integers, which is the horizontal delay in milliseconds, vertical delay in milliseconds, and yellow delay in milliseconds, so that we can have these as variables that can be changed by either external input from, for example, the detection sensors, or if we're going to make this into an actual user interface that might be used in a real-world application where an operator can go in and say, okay, I decided we want to change those delays. We can have an input panel here where you can actually change those values based on different flow rates for the traffic and so on. So the first thing we want to do is set those values as variables. And then what we're going to do is we're going to go into this and we're going to add those as externally changeable values that an operator can change. So let's see how we can do that. So now I've gone ahead and made some very minor modifications to our application. And the goal here is to make it so that we're better prepared to implement, for example, the occupation detection sensors or any other inputs, and also to make this user interface so it's closer to what we might think would be used by an actual operator or technician in the real world to configure and modify this for the particular intersection and the traffic flows and so on. So what I've done is I brought out the values that we had hard-coded into some text boxes with some labels, and I've got a delay, how many seconds the horizontal traffic has a green light for. There's a 10-second delay to give them a green light for 10 seconds. Actually, it's probably more like 60 in most cases. And then the vertical delay for the up and down traffic, they've only got 3 seconds. And then the yellow is going from green to red. We have a 2-second delay of a yellow signal to tell traffic to slow down. I've also added an intermediate delay. And we can see what the intermediate delay is. When we've got green, we've got the green that goes to yellow and then red, and then there's a 1-second delay to make sure that the red has turned red before we go green as more of a safety thing. So that's the intermediate delay. So here is our updated application, and we can manually set the delays, and this will allow us to also use the occupation detection sensor to internally modify those delays. So in our application, I've just added 4 variables, integers, horizontal delay milliseconds, vertical delay milliseconds, yellow delay milliseconds, and intermediate delay milliseconds. And then when I start up the Form 1, I just enter these default values into those text boxes. And these are in seconds so that the operator can use them in seconds. And then we've got our supervisor async, set state. And the only thing we've done here in the set state is referred to these variables. Here we've got the intermediate delay, the horizontal delay, intermediate delay, the yellow delay, and then intermediate and vertical, and then intermediate and yellow, and then it loops back. So we've just added those, and we've got these labels and text boxes. I'll assume you know how to do that. So now we're starting to get a user interface that is more like an actual real-world technician interface. And now we can start thinking how we can implement the occupation detection sensors. So the simplest implementation of the occupation detection sensors is if a car pulls up to a red light, it will speed up the state transition to go to the next state, so that we'll ultimately get a green light on that car that has a red light. So you can see in state 1, for example, we've got red lights on these 2 vertical lanes. if a car pulls up to, we call this sensor 1, we've got them numbered 1, 2, 3, and 4. If a car pulls up to sensor 1 when it's got a red light, or a car pulls up to sensor 3 with a red light, either of those will initiate a faster state change so that these reds will turn to green. So state 1, sensors 1 and 3 are going to speed up a state change. Now what about state 2? Well, state 2, the cars are already there and it's already a transition state. It's a yellow. It's in the process of turning to a red for these yellow lights and a green, so we really don't have to worry about state 2. However, in state 3, we have the same case, but for cars coming up to a stoplight on the horizontal lanes. So if a car comes up to sensor number 2 or sensor number 4 in state 3, it might initiate a faster state change so that those reds will turn to greens. And then with state 4, we have the same thing. It's a transition, so we don't really need to worry about the occupation detection sensors. We can kind of ignore them, at least for this simple implementation. So in state 1, sensors 1 or 3 will initiate a faster state change. In state 3, sensors 2 or 4 initiate a state change. And then in the intermediate transition states, where they're yellow lights, states 2 and 4, the transition states mean that the sensors are going to be ignored. So let's look at our code and see how we might, for these two states, how we might initiate a state change when either of these two, we can assume they're booleans for the sensors. If a sensor 1 or 3 is true, and in state 3 sensor 2 or 4 is true, how do those booleans initiate a faster state change? So let's take a look at our code. So that's it for this one. Honestly, I know I'm not going to get very many views in this series. Most of these concepts are far too complicated for people. They lose interest after the first video in the series. And here we are on video 4. I know nobody's going to be watching this. So I think I'm going to end it here. If I get any views, any people show any interest, we can continue. But at this point, I think we're about done with this series. So if you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications. But most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.